Okay, we're going to start talking about 9.4, section 9.4, which is multiplying and dividing radical expressions. Now we did a little bit of multiplying and dividing in 9.3, but we're going to continue on and we're going to learn how to simplify problems that are a little bit more complex. So considering this, square root 30x times square root 2x to the fourth, if I were going to simplify, I really can't simplify 30x because that is 2 times 3 times 5, and then times x. That doesn't actually simplify anywhere, so that doesn't help me. Now, square root of 2x to the fourth, I can pull this out to be x squared times the square root of 2, but this doesn't actually simplify my original problem a whole lot. So instead what I'm going to do is I'm going to combine the radicals first into one radical, make this the square root of 60 x to the fifth, and then look for those perfect square factors. So 60 is really 4 times 15, so square root of 4 times square root of 15. And then x to the fifth, I can say that's really x to the fourth times x. So square root of x to the fourth times square root of x. Then I can simplify. This is 2, and this becomes x squared. And I'm left with square root of 15 and x, and that's my simplified answer. Okay, so consider cube root of 3 times the cube root of 18. Well, that becomes the cube root of 54, which now when I'm thinking of my perfect cube factors, I really know that that's the cube root of 27 times the cube root of 2, which gives me 3 times the cube root of 2. Simplified. If I have here the square root of 8x to the 8th y to the 3rd times the square root of 22 x to the 4th y to the 3rd. First things first, think about this as one radical, so it's going to give me square root of 176, and I'm going to have x to the 12th and y to the 6th. So really, I'm looking for a perfect square factor of 176. And that is really square root of 16 times the square root of 11. So when I simplify that, and then I have, of course, the x to the 12th and the y to the 6th. So this becomes a 4, and inside my radicals stays my 11. When I think about how many x's are there, how many x squareds are there here? Well, x to the 12th is really x to the 6th squared. And of course, you know, I'm taking the square root of this. And similarly, y to the 6th is really y to the 3rd squared. So this becomes 4 x to the 6th y to the 3rd. And then the square root of 11. So I want you to think about multiplying your, we're going to think about multiplying radicals, and we're going to do it the same way in which we multiplied polynomial expressions. So thinking back here, if I were to multiply this, I would get negative 28 x squared, and I'm distributing here, and I would get a positive 35x. Similarly, over here, when I use that multiplication method, some people remember it as FOIL, I multiply my first terms, which gives me 2x squared, my outside terms, which is 14x, my inside terms, which is a minus 3x, and my last terms, which gives me minus 21. When possible, I have to combine like terms, which have 14x minus 3x gives me 11x, and then minus 21. Well, now we're going to do the same thing with our radicals, okay? So let's see how this works. 2 times the square root of 5 times 3. Well, 2 times 3 is 6, so 6 square root 5. And then here, I'm saying 2 radical 5 times minus 9 square root 5, so that becomes minus 18. And then my radicals, radical 5 times radical 5 becomes radical 25. Well, but radical 25 is really 5. So this becomes 6 square root 5, or 6 radical 5, minus 18 times 5. So we have to figure out what 18 times 5 is. Well, that's 90. So this becomes 6 square root 5 minus 90. Okay. Remember, I cannot combine these because one has square root 5 and one doesn't. If they both had square root 5s, we could put them together. All right. We're going to use the FOIL method, or multiplication distribution method, just like we did in our previous up there. So this becomes, first is 2 times 1, which is 2. Outside is 2 times 7 square root 2. So that becomes 14 square root 2. Our inside becomes negative 3 square root 2 times 1 minus 3 square root 2, excuse me, not square root 3. And then our last becomes negative 3 square root 2 times 7 square root 2, so that's minus 21 square root 4. When possible, I can simplify and combine like terms, so this becomes plus 11 square root 2, and then minus 21 times the square root of 4, well the square root of 4 is 2, so minus 21 times 2, which is 42. So this gives me, I can write it as 11 square root 2, and then a plus 2 minus 42 is minus 40. Okay? So now let's take a look at a couple more problems and see how these play out. Okay, I'm just distributing here, so this becomes the 4th root of x to the 6th minus the 4th root of 3x squared. Well, the 4th root of x to the 6th becomes x times the 4th root of x squared minus the 4th root of 3x squared. Well, can I combine those together? Well, this is the 4th root of 3x squared, and this is the 4th root of x squared. So they're not like radicals. I cannot put them together. Okay. Similarly here, my first term gives me a 3x squared, and then I have a minus 3x times the cube root of 9, and then my inside term is a plus 2x times the cube root of 3, and then my last term is a minus 2 times the cube root of 27. Okay? I can combine my terms that are like, so this gives me a 3x squared. I can't actually combine these because remember, one is a cube root of 9, one is a cube root of 3. So I cannot combine them. They are not like radicals. But the cube root of 27 is 3, so 2 times 3 is 6, so this is a minus 6 when all is said and done. Okay, that's all for this one. Keep up the good work. We'll see you in the next video.